Welcome everyone, and we are today going to start with board revisions. By board I mean class 10th. Uh, See, in class 10th we have different courses for CBSE, ICSE, for different state boards. But I have noticed that almost all the boards have the same chapters, especially in mathematics and science. So we generally have no difference between the boards and no difference in the question patterns as well. Yes, the marking scheme or the module or the paper set is different, but the basic concepts of mathematics and science almost remain the same. So what I am going to discuss today is just a gist of all these things, and some questions which might seem to some people or some students at a difficulty level. So obviously the purpose here is to ensure that you get more and more confidence. If you happen to have the basic concepts clear about different forms of questions in mathematics, obviously these questions are never going to pose a huge problem for you. So we are going to get started with this, and I am going to touch base with all the things, all the aspects of mathematics, whether it is algebra, whether it is arithmetic progressions, or whether it is quadratic equations. So I am sure till now you must have some idea about, as there is hardly any time left for all these board examinations that are coming up. I am sure that you must have gone through the various aspects of mathematics, and it will not be a very difficult thing for you to grasp the concepts. So I am not going to start with the basic concepts about because we hardly have any time left. So I am just going to solve some questions for some students which might be difficult at a level, but if we have the concepts clear, it will be a smooth cakewalk for all of us. So I would expect you to cooperate and watch this video at full length, so that you have a clear conception about all the things that we are going to discuss right now. Okay. Alright, so we will start with questions as they come. I am not going to be very specific about to which chapter they are related to. I am going to give you a hint as to what they are correlating to. At times you might have a question which might relate or correlate to both the aspects, like let's say if you have a question which might connect the concepts of quadratic equation to an arithmetic progression, or maybe anything of that sort. So let's kind of get started with this. So we are going to do a revision. Basically this is for mathematics for students who are going to appear for their class 10th examination, and when I am saying mathematics, it covers various aspects. So the problems that we are going to get in touch today are primarily related to arithmetic progressions. We'll then move on to linear equations, then we have quadratic equations as well. So as and when we kind of go ahead and deal with these problems, we will have a clear concept of how to deal with them. Alright, so let's get started. We have a problem here. I will straight away start with the problems out here and give you the tips as to how to solve these questions. Obviously these questions are of a little more difficulty level than what you generally start when you start with the chapter. So let's get started. The first question that we have here is find the condition that the equations ax square plus bx plus c is equal to 0 and a1x square plus b1x plus c is equal to 0 may have a common root. Find this common root when it exists. So just look at this question. Find the condition, let's get this separated out here. Find this condition when the equations ax square plus bx plus c is equal to 0 and a1x square, sorry, we have here ax square plus bx and a1x square plus b1x plus c is equal to 0 may have a common root. Now these two equations you see have a common root. That's the situation that has been given. We all know that there are two roots for any kind of quadratic equation, as it is a quadratic equation. So we will have two roots to it. Now what we need to find here is that there is a common root to both these equations. So let's get this started out here. Okay, so we have here x square bx plus c is equal to 0 and a1x square. Now what we need to do here is we have a term which is in x square and we have a term which is in x. we have a term in x square, we have a term in x in both the equations. So obviously the conditions or the values of x which are going to satisfy this equation are going to satisfy this equation as well. So as we do, see, as I said, the concepts here are going to be a mixture of various aspects of mathematics. Now let's say if you are talking about quadratic equations, we know how to calculate the roots of an equation, but in this case we will also inculcate the basic techniques of simultaneous equations. See, when you solve a simultaneous equation which has basically two variables, you subtract the equations and then you eliminate one of the variables. The same concept is going to be followed here as well. So you have two equations here which are in the quadratic format. However, if you have to solve this, you will have to apply the concept of linear equations. Okay, so let's get this started. If I have this first equation, ax square plus bx plus c is equal to 0, and the second equation is, so let's first get this started. So second equation is a1 x square plus b1x plus c is equal to 0. Now have a close look at both these equations. I have to eliminate one by one either the x square or the x. So if I need to intend, or rather I want to eliminate this x square, what do? I have to equate the coefficients of both these, which we generally do in simultaneous equations. This has a coefficient of a, this has a coefficient of a1. If I have to equate the coefficients of these two, which means that I am intending to eliminate the x square from this equation. So if I have to eliminate this, I will get this entire equation multiplied by a1, and this entire equation I get it multiplied by a. So what do I get here? This will be a1 x square plus a1 b x plus a1 c is equal to 0. It's a modified form of this equation. So we get this numbered as equation 1. Now what about this equation? We get this multiplied by a. So what do we have here? a1 x square plus a b1 x plus a c is equal to 0. This is the second equation. Okay, so let's get this sorted out. a1 x square plus a1 bx plus a1 c is equal to 0. This gives you the equation number 1. And a1 x square plus a b1 x plus a c is equal to 0. This gives you the second equation. What we need to do here is just a common thing that we do in all forms of linear equations, subtraction or addition, depending on what you need to eliminate. Now we see these two terms are equal, so we get them subtracted. So this obviously gets cancelled. We are now subtracting this one from this one. Obviously x is going to be common out here. So we have here x a1b minus ab1. So this one is a1b minus ab1 into x, plus this will be a1, and here we have c as common in both of them. Okay, here we have c1, I'm sorry. So this would be c1. The equation that has been given is c1. So the first equation will be of c, the second equation will be of c1. So here we have a1c minus ac1 is equal to 0. Now if I happen to transpose these terms there, why? Because I need the value, I need to isolate this x here. So a1b minus ab1 into x is going to give you ac1 minus a1c. I'm just transposing these terms there. So since it is in the plus format, when it goes there it becomes minus. Since it is in the minus format, when it goes there it becomes plus. So what do we have here? X is equal to ac1 plus a1c upon a1b minus ab1. So here you get the value of x. Now it's just not that this x, we have to satisfy the equation in terms of x square as well. So now what we need to do is we need to eliminate this x and get the value in terms of x square. So what do we need to do this? In this case we have to ensure that we get these two coefficients equal. So in this case, let's say ax square plus, the first equation is bx plus c is equal to 0. We get this now multiplied by, now look at the second equation here, a1 x square plus b1 x plus c1 is equal to 0. What we are targeting this time is to eliminate this one. In order to eliminate this one, as we follow the concepts of linear equation, we get this multiplied by b1 and we get this multiplied by b. So what do we get here? A b1 x square plus b b1 x plus c b1 is equal to 0. What do we get here? A1 b x square plus b b1 x plus c1 b is equal to 0. Now we get this subtracted out here. So let's say we have a third equation and we have a fourth equation. If I happen to subtract this, as you can see, this will get cancelled. So what do we have here? A1b minus a1b, this would be x square. So since this is minus, this is already taken care of. What do we have here? cb1 minus c1b is equal to 0. Now we'll just transpose these terms there. So we get a1b minus a1b x square is equal to, now when I transpose these terms, obviously their signs are going to change. So what we have here is c1b minus cb1. If you notice, this one goes there with a plus sign, it becomes minus. This minus goes there with a plus sign, with a minus sign, it will become plus. So with x square, we are left with c1b minus cb1 upon ab1 minus a1b. So here we have for x square. So this would be the condition. Okay. And now if we happen to just square this off, so if I square both the sides out here, squaring both sides, so we will get x square is equal to ac1 plus a1c upon a1b minus ab1 whole square. So since both will have the same values, as x is the common root between both of them, so let's just name this here as fifth equation and sixth equation. So we can write here from 5 and 6 we will have ac1 plus a1c upon a1b minus ab1. The square of this is going to give you c1b minus cb1 upon ab1 minus a1b. So this is the condition of both the equations getting justified. So as you see, this might seem to be a difficult problem, but the only concept that we are involving here is the concepts of quadratic equation as well as the concept of linear equations. How are we involving this? We are at one time getting rid of this, and the other equation we are getting rid of this. So by getting rid of x and x square, we are getting the condition when both of these will be equal. So have a common root. What would be the common root? This would be the common root, that is ac1, and if you have to find the value, then this will be the value ac1 if find this common root when it exists. So this is the condition and this is the common root. So if I have to correlate this to the common root is x and this is its value. And what is the condition? Find this common root when it exists. So what is the condition? The condition would be, this one is the condition. So the common root is this one and this is the condition when both of them will be having a same roots. We'll quickly switch on to the next format of the problem, and as and when we carry on, these might seem to be a little difficult problems. However, I am sure that if you get the concepts clear here, then you will not face a problem in cracking your boards, because these will inculcate problems. The purpose of solving these problems for you is to ensure that you have a very clear concept about things, so that we generally do not goof up at the board. Okay, now let's move on to the other one. We have here, find the value of t when the equations 3x square minus 2x plus p is equal to 0 and 6x square minus 17x plus 12 is equal to 0 have a common root. So they have a common root, very much similar to the previous problems that we have dealt with. 6x square minus 17x plus 12 is equal to 0, and this is a format wherein you have an unknown c out here. Basically ax square plus bx plus c is the format of a quadratic equation. In this case the c part is known, but in this case the c part has been replaced by a p. So let's quickly figure this out, how to deal with this. Again, this is a format of quadratic equation. So we'll just deal with this one first. So as we can see, 6x square minus 17x plus 12 is equal to 0. This can be sorted out as a quadratic equation itself. We know how to sort this out. We'll get these two multiplied. So 12 into 6 will give you 72. Basically what we are doing is splitting up the midterm. So 12 into 6 will give you 72. From 72 we have to actually correlate two factors so that we can obtain a 17. So here we have 9 into 8 and 9 plus 8 will give us 17. So we have 6x square minus 8x minus 9x plus 12 getting a value of 0. So if we happen to solve this out, between 6 and 8 we have 2 as common, 2x, so 3x minus 4 minus, if we happen to, between these two we will have 3 as common, so this will be left with 3x minus 4 is equal to 0. So we have 2x minus 3 into 3x minus 4 is equal to 0. So as we have been solving quadratic equations, so either 2x minus 3 in this case will be 0 or 3x minus 4 will be equal to 0. So what we have here is x is equal to 3 by 2 or x is equal to 4 by 3. So we have gotten the value of x. Now obviously the values of x taken out here will satisfy this equation as well as per the given condition when the equations have a common root. So obviously this will be the, so when x is equal to 3 by 2, what do we get here? 3, we will replace the value by 3 by 2 square minus 2 into x, that's going to be 3 by 2 again, plus p, this is going to get us 0. So what do we have here? 3 into 9 by 4 minus 6, obviously this 2 get cancelled, so we will have 6 plus p is equal to 0. This is going to give you 27 by 4 minus 6 plus p is equal to 0. Let's quickly check this out. This is 9 by 4 and multiplied by 3, okay, minus 2, this gets cancelled, so you have here 3, I'm sorry, it's better to check. Okay, so we have here 3. Now this is going to give you how much? 27 minus 12 plus p is equal to 0. So this gives you 15 by 4 plus p is equal to 0. So therefore the value of p is going to be minus 15 by 4. This gives you one part of the equation. We are not yet done with putting the values for the second equation. So if we have 3, now putting x is equal to 4 by 3. So what do we have here? 3x square, which means 4 by 3 square minus 2 into 4 by 3 plus p is equal to 0. So this will be 3 into 16 by 9 minus 2 4s are 8 by 3 plus p is equal to 0. So this gives you 16 by 3 minus 8 by 3 plus p is equal to 0. This gives you 8 by 3 plus p is equal to 0. So therefore your p is going to be minus 8 by 3. A little simpler than the previous problem that we dealt with. So p will have two values, that is minus 15 by 4 and minus 8 by 3. So as you can see, we have solved this quadratic equation. What we did is we first calculated the roots of this equation, we just placed it here. What students generally make a mistake here is that they do not substitute the value of the other quadratic or the other root into this equation. So p is going to get you two values. By putting one value you get minus 15 by 4, by putting the other value you get minus 8 by 3. So this is how we are going to solve the equations out here. We will move on now to the next problem. Okay, so what we have here, if the sum of the quadratic roots, this is the third problem that we are dealing with, if the sum of the roots of the quadratic equation ax square plus bx plus c is equal to 0 is equal to the sum of the squares of their reciprocals, then show that bc square, ca square, ab square are in AP. Okay, just look at this question. If the sum of the roots of the quadratic equation, we know that for every quadratic equation there are going to be two roots. Ax square plus bx plus c will obviously have two equations, is equal to the sum of the squares of their reciprocals. Then show that bc square, ca square and ab square are in AP. So if you see that we are going to involve the concepts of both quadratic equation and AP into this. So let's quickly check this out. Ax square plus bx plus c. So obviously if I consider this equation, ax square plus bx plus c is equal to 0. If let's say let the roots be alpha and beta. So what do we have here? Alpha plus beta is going to give you minus b by a. This is the concept of quadratic equation. When we sum up the roots, we get minus b by a, and alpha into beta is going to give you c by a. Okay, so how do we solve this now? If the sum of the roots of the quadratic equation, so alpha plus beta is equal to the sum of the squares of the reciprocals, which means 1 by alpha square plus 1 by beta square. Obviously the reciprocal of alpha will be 1 by alpha and the reciprocal of beta will be 1 by beta. So if the sum of the roots is equal to the sum of the squares of the reciprocals, so this is the given condition. Okay, so we'll quickly look as to how we can twist and tweak this given condition. We have here alpha square plus beta square. Obviously if we happen to add them up, this will be alpha square plus beta square, alpha plus beta. Now just look at this equation. For what things do you have a value? We have a value for this, we have a value for this which has been given to us, we don't have a value for this. So how do we calculate this? It's easy. Alpha square plus beta square. So if you look into this, alpha plus beta whole square we know is equal to alpha square plus beta square plus 2 alpha beta, which means if I were to calculate and isolate alpha square plus beta square on this side, this goes here, so this becomes alpha beta square minus 2 alpha beta. So this can be written as alpha plus beta whole square minus 2 alpha beta, and this becomes alpha beta square. We can add in this way, this becomes alpha plus beta. Now we are just going to put the values here. What do we have in place of alpha plus beta? We have here minus b by a. What do we have in place of alpha plus beta square? We will have minus b by a, and this is square, minus 2 alpha beta, which means 2 into alpha beta, that's going to be c by a. Then we have alpha beta square, which means c by a, this square. So what do we have here? Minus b by a is equal to b square by a square minus 2c by a, and this whole thing upon c square by a square. So what do we have here? Minus b by a is equal to b square. If we happen to take this as common LCM of a square, we will have here a square. So b square remains unchanged. For this you have to multiply this with a, so obviously you multiply that numerator with a as well. So this becomes minus 2ac upon this becomes c square by a square. Now look at this carefully. Both have the denominators as a square, so both of them get cancelled. So what we are left with is b square minus 2ac by c square is equal to minus b by a. We just do a common cross multiplication. So by cross multiplication, what do we get here? Minus b c square is equal to, we get this multiplied, a b square minus 2ac. So what it is going to give you? B c square is equal to a b square minus 2a square c. I hope we are on the same page till now. See, a b square a into, so this is going to give you. Now what do you have to prove? See, we have to look into this as to how we can prove that this is a AP. So in this case we just split up this term. Minus 2a square c can be written as minus a square c minus a square c. This is going to give you minus 2a square c minus bc square. If I get this here, so this will be a square c minus bc square is equal to a b square minus a square c. So this is going to be a square c minus bc square ab square minus ac square. Look at this very carefully. This term and this term are alike, and this happens where, so let's say if we have three numbers x, y and z in AP, and if they are in AP, then they will have a common difference, which means that we can write y minus x is equal to z minus y, and this is very much similar to what we have got here. Look at this very carefully, y minus x z minus y. So therefore we can say that a square c, so this becomes your midterm, that is y, a square c will become the midterm, bc square will obviously become the x part, which is bc square, and ab square will become the z part, which is ab square. So thus these three numbers therefore are in AP. We can write the reason here, since they have a common difference, we can say that bc square, a square c and ab square have, or rather in AP. So we have used two concepts out here. One concept is from the quadratic equation and the other concept is from AP. Are we clear on this one? Okay. If there are any doubts, please do feel free to post your comments in the comments section and I will get this clarified. So as you can see that all through these problems we are actually incorporating all the concepts of mathematics, whether it is from quadratic equation, whether it is from AP. So people generally get confused as to how this can be correlated to an AP. If this is the problem with students is that they feel that the entire subject of mathematics can be formatted, and that's not the case. We have to involve things from different concepts. So obviously when you get an equation of this format, the first thing that comes into your mind, it has to be solved as per the basic concepts of quadratic equation, which we did. However, this has to be incorporated with an AP as well. So you have to have the concepts very clear as to how the situation can be twisted and tweaked so that we can get the result in the form of an AP. So these are some questions which might seem to be a little difficult, but then if your concepts are clear, it should be a cakewalk. We'll deal with other problems next time.